Hello, I'm going to show you my visual odometry and how it behaves on this data set. This is something I shot at home like several months ago, I guess, or maybe years, I'm not sure. So this is like the camera is moving backwards, then sideways. It moves slowly because it's quite challenging to solve the problem with a fast moving camera. So let's show the algorithm. So we start with this initialization of the first keyframe. It's just randomly, it has random depth between some values, and then we start the algorithm. It immediately creates somewhat good approximation, but it's actually quite a bad approximation because the camera is moving only forward and backwards. That's why we have this problem here, which is the epipole, the central line in front of the camera, which we cannot really solve well the disparity there, and this depth has very high variance. But it's nothing to worry about because eventually the camera will move sideways and this will be solved. For now, the algorithm works at about 1 frame per second, maybe a little bit faster than that, and the creating of a new keyframe is quite slow, but I haven't optimized a lot of the things. So okay, we started moving sideways, I think. No, we haven't actually. This is just a small movement of my arm, and we're going to continue backwards. The trajectory is surprisingly accurate. I'm not sure why it happens, but anyway, another interesting thing is that from the sideway we really have a bad approximation. We really have a very bad view, but if we look at the very center and move forward and backwards, you see that it's quite a lot better, the reconstruction. The reason is that this really represents only one movement in the back, so that creates that's the reason for this problem. But when we start moving sideways, it's going to have a very nice stereo images, so it's going to create a better 3D reconstruction. But for now, it's going to take some time. Okay, so it started moving sideways. You can see the trajectory, so it moved backwards. Now it's moving to the left. And now we have a way better reconstruction. So this here, it's the chair, this is the bookshelf, and this is the desk. You can see them on the left. This is the current frame that is being processed. This is the floor here. Now it's moving towards a better floor, but so yeah. And in my previous video, I showed you how I had a big problem with noise, which I solved by tracking not just single pixels, but rather these colorful parts, which are segments of the image, and they really solve the mismatch problem. Oh, actually, I lied to you. This is the current frame being processed. Anyway, now the camera is starting to move to the right, and we can see the trajectory. Oh shit. The trajectory is going to the right, and it moved to the left. And that's what I wanted to show you. Now I've implemented the convergence from a random point cloud to a somewhat good 3D model, and the next step is to optimize the code more, because right now it runs, as I said, 1 frame per second. And that's it for now. I hope you like what I'm doing.